Hey everyone, and welcome. Have you ever looked at a probability problem and felt like you were trying to read a completely different language? All those symbols, all those formulas? It can be really intimidating. But what if I told you there's a way to actually see the answer without memorizing a single equation? Well, today we're going to do just that. We're going to unlock probability using pictures. Let's dive in. So, does this look familiar? Just a total sea of symbols and letters that feels, well, completely abstract and confusing. Look, we've all been there, right? You're trying to cram formulas for one type of problem, and then the next one comes along and you're completely lost. It's a super common struggle. But why is it so hard? Here's the thing. Your brain is not a computer. It's wired for stories, for patterns, for visuals, not for abstract code. Trying to learn probability with just formulas is kind of like trying to learn how to swim by reading a book about it. It just doesn't work. You need to actually get in the water. You need to see what's happening. And today, we're going to do exactly that, with 3 incredibly simple visual hacks. Okay, hack number 1 is the box method. This is just a brilliantly simple way to make sure you see every single possible outcome in a problem. Seriously, no more missing possibilities, no more simple counting mistakes. Let me break this down for you. So let's take a classic problem. You're going to toss 2 coins. Instead of trying to list the outcomes in your head, we just draw a simple grid. We'll label one side for the first coin, heads and tails, and the top for the second coin, heads and tails. Then you just fill in the boxes where they meet. So that top left box, that's heads from coin 1 and heads from coin 2. The one next to it, heads from coin 1, tails from coin 2. You see? And bam! Just like that, you can literally see all the possibilities. Heads, 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 tails, tails, heads, and tails, tails. There it is. 4 total outcomes, all laid out perfectly. You see how this turns an abstract list into a solid, organized picture? This is a total game changer. All right, now let's use our new visual to answer a question. What's the probability of getting at least one head? No formulas needed, just look at the box and count. Okay, we've got heads, heads, that has a head. Heads, tails, that one too. And tails, heads, yep, that's 3 boxes that fit what we're looking for. So what does that mean? The answer is simply 3 out of the 4 total boxes. That's it. The box method gave us the answer just by looking. This is perfect for any problem with 2 separate events, like rolling 2 dice or picking from 2 different menus. So simple. Okay, let's move on to our second hack. This is for problems that happen in a sequence, one after another. Think of it like drawing a roadmap for your probability journey. We're talking about tree diagrams. All right, here's a super typical scenario you've probably seen. We've got a bag with 3 red balls and 2 blue balls. We're going to pick 2. But here's the key. We don't put the first one back. That little phrase, without replacement, that's where people get tripped up. But our roadmap is going to make it crystal clear. So right at the start, what's our chance of picking a red? Well, there are 3 red out of 5 total, so 3/5. And for blue, 2 out of 5. Easy enough. We start with our first pick. So we draw 2 branches, one for red, one for blue. Now this is crucial. Let's say we went down that red path first. What's left in the bag? Think about it. There are only 4 balls left, and only 2 of them are red. So the probability changes for our second pick. The tree diagram forces us to see that, updating the chances at every single step. So if someone asks, what's the probability of picking 2 red balls in a row? We just follow the red path on our roadmap. And to get the final probability, you just multiply the chances along the branches you took. So that's 3/5 times 2/4, which gives us 6/20, or 3/10. The tree diagram just illustrates that journey perfectly. Our final hack is an absolute secret weapon for any problem that throws around words like and, or, both, or only. The Venn diagram. And it's way more than just a couple of overlapping circles. It's a tool for sorting out confusing groups with total clarity. Now listen carefully, because this is the #1 mistake everyone makes. They see 30 past math and they just write 30 in the math circle. No. The secret to Venn diagrams is you always start from the middle, from the overlap. We know 15 students passed both, so we put 15 in that intersection first. Then we figure out the only sections. So the number who passed only math is the total of 30 minus that 15 in the middle, which is 15. And only physics is 25 minus that 15, which is 10. See the difference? So now that we have our diagram filled out the right way, we can answer this question so easily. First, let's figure out how many students passed at least one of the subjects. We just add up all the numbers inside our circles. The 15 who passed only math, the 10 who passed only physics, and the 15 who passed both. That gives us a total of 40 students. And since we know there are 50 students in the whole class, we just subtract those 40 students from the total. So 50 minus 40 leaves us with 10. Boom! 10 students failed both. That Venn diagram turned a confusing word problem into simple addition and subtraction. So there you have it. You don't just have 3 tricks. You have a powerful visual toolkit to go out and attack probability problems. Instead of seeing a scary wall of formulas, you can now see the problem for what it really is. All right, let's do a quick recap. Use the box method anytime you need to see every single combination of 2 separate events. Use tree diagrams when things happen one after the other, especially when those probabilities change along the way. And you pull out that Venn diagram superpower for any problem with overlapping groups. Oh, and as a little bonus, don't forget that a simple bar chart is an amazing way to visualize statistics. The tallest bar, that's your mode. You can see it instantly. So the next time you face a probability question, don't reach for a formula sheet. Reach for a pen. Draw the problem. Because I promise you, once you can see it, you'll understand it. The only question left is, what are you going to visualize first?